Hello, kids. I'm Chavi Bansal. Hope you already know me. In the last video, we were talking about the basics of mole concept, right? We discussed so many things. We discussed so many formulas. We discussed what is molar mass, what is mole, and all that, right? We also did very important formula where how to calculate the number of moles or how to calculate the number of atoms, right? So today we are going to continue with that. We are going to do certain questions on that formula, and after that we are going to do new concepts as well. So let's start. Let me share my screen. Okay, I hope you guys are able to see my screen. So the very important formula that we did there was number of moles is equal to grams given divided by molar mass. It is also equal to number of entities given by Avogadro's entities. Okay, these are the two formulas which we can use to calculate the number of moles. Okay, for example, let's find out the number of moles. Number of moles of oxygen atom present in 32 grams of oxygen. Now, this is one question. Fine. Always try to understand when you get a question, what is given and what we have to find out. So here we have to find out the number of moles means this one, right? What we are given with the grams. And we already know the molar mass of oxygen. Molar mass of oxygen is 16 grams. So what we can do is, we can use this formula. Let me highlight it for you guys. We can use this formula to find out the result. So number of moles equals to grams given divided by molar mass. It can be, what is the gram given? 32 gram. So 32 gram divided by what is molar mass? 16 grams per mole, right? And we'll get 2 moles. So number of moles of oxygen atoms in 32 gram of O is 2 moles. Clear? This is the easiest way of doing the question. Now, in this formula, instead of using molar mass, we can use different things also. For example, number of moles is equal to gram given by gram atomic weight or gram atomic mass. You remember when we were talking about this thing, molar mass, what is the mass of 1 mole of the atoms and all that? At that time, I also told you the molar mass is also equal to gram atomic mass. Okay? If we are talking about the number of moles. If we are talking about the number of molecules, moles of molecules, then it will be equal to gram given by gram molecular mass. Okay? This is for number of moles of molecules. This is number of moles of atoms. Okay. So whatever the entity is here, same entity we can find out. Same way, whatever the entity is given here, we have to correspondingly use the same mass to find out the number of moles. Okay. For example, let's do a question. So the question is, okay, before we go to solve the question for this gram atomic mass and gram molecular mass, let's solve the question for this one bit formula. Okay. Now, for example, find out the number of atoms of carbon present in 48 grams of carbon. Okay. Now, what we are given? We are given with given mass, right? What we have to find out? We have to find out the number of atoms. Now, if you see this formula, there is a way of going there. if they are grams given and you know the molar mass, you can find out the number of moles. And if you find out the number of moles and you multiply it with Avogadro's number, you will get the number of entities, right? So here, the number of moles is the central part. For example, here, what is gram given? 48 grams. What is the molar mass of, or instead of molar mass, gram atomic mass of carbon is 12 gram, right? So what will be the number of moles? Number of moles will be equal to gram given by gram atomic mass, which is equal to 48 grams by 12 gram per mole. So how many moles it is? 4 moles, right? Now this is the first part. This part we have solved. Now we have got the number of moles. We have to find out the number of entities. So we know the number of moles is equal to number of atoms of carbon divided by Avogadro's number of carbon atoms. Okay. How many number of moles we have? We have 4. Let put this value equals to x. X divided by 6.022 into 10 raised to 23 atoms. So what we'll get? X is equal to 4 multiplied 6.022 to 10 raised to 23 atoms of carbon. Or if we do the multiplication, 880, 6 4s are 24. 24 into 10 raised to 23 atoms of carbon. Okay, is it clear? This is the basic way of doing such questions. See, this formula, that's why it's very, very, very important. If you know the grams, you know the molar mass, you can find the number of moles. Once you get the number of moles, you can always find out the number of entities. Okay. Now, right now, this looks very simple. Okay. But this simple concept has been used in many times in the exams. Okay. For example, you might have heard the question, which of the following has highest number of oxygen atoms? A, 16 gram of O2. B, 32 grams of SO2. C, 63 gram of HNO3. And D, 49 gram of H2SO4. Okay. Now we have to find out the oxygen atom, right? What we are given with? We are given with grams of molecules. Okay. So let's forget what we have to find out. Like, is it atom or a molecule? Right now, let's consider we are given with the weight of the molecules. So from this weight, from A part, can I write number of moles equals to 16 divided by, what is the mass for O2? 32 gram, right? O2 molecule. That is 32 gram per mole, which will give me 0.5 mole. Now, 1 mole contains Avogadro number. So, number of oxygen molecules in this much will be how much? 0.5 into 6.022 into 10 raised by 23 molecules. Right? Now we got the molecule. Now we know that each molecule of O2 has 2 atoms of oxygen. So, by multiplying it with 2, I will get the number of atoms. Number of O atoms is equal to 2 multiplied 0.5 into Na, right? 2 into 0.5 is 1, which is equal to Na number of atoms. Fine. This is part A. Same way for part B, 32, I'm just doing the calculation directly. 32 gram divided by what is SO2? 32 plus 32, which is 64 grams. So 64 grams per mole, which gives us 0.5 mole again. And then each molecule has 2 oxygen atoms. So this will also give 0.5 into Avogadro's number, which is Avogadro's number of oxygen atoms. So these both are same. So let's not keep it. C. 63 grams of HNO3. Let's find out what is the molecular weight of HNO3. H is 1, N is 14, O3 is 48. 63. So, number of moles of HNO3 equals to 63 grams divided by 63 grams per mole, which gives us 1 mole. Okay. Now, one molecule of HNO3 has 3 atoms of oxygen, right? So, 1 mole also have 1 mole of HNO3 has 3 moles of oxygen atom, which is equal to 3 into Avogadro's number, right? D part. We have 49 gram of H2SO4. So 49 gram for H2SO4, it's 2, S is 32 and 64. 98. So 98 gram per mole, which gives us 0.5 mole. And each mole has 4 oxygen atoms, right? So 0.5 into 4 into Avogadro's number, that will give 2Na, right? This is 2Na, this is 3Na, and rest is Na only. So this is the correct answer. 63 grams of HNO3 contains maximum number of oxygen atoms. Okay. And here what I used gram atomic mass. Fine. No, sorry, gram molecular mass, because here everything was in molecule. Clear? Any doubt? Such type of questions repeatedly come. So when it comes into the JEE or NEET exam, you do not have to follow such a long calculation. It's in mind, you can just find out, okay, this much is the gram, this is the molecular weight, what are the number of moles? If you find out the number of moles of that atom also, it is one and the same thing. You can compare that also, because each mole contains Avogadro's number. If it is corresponding number of moles of the atoms also, you are able to find out, you'll be able to solve the question. Fine? Any doubt so far? Similarly, there is another type of question, like similar type of question that also comes, which has least number of atoms. Okay. 14 gram of N2, 16 gram of um, S8, 10 gram of C6H12O6. Okay. Least number of atoms. Atoms in the sense, any like total number of atoms that are present. Okay. So again, how we will solve? Number of moles. What are number of moles here? 14 divided by 28. That gives us 0.5 moles of N2. So now if it's 0.5 moles of N2, we will have Na number of nitrogen atoms. Why? 0.5 multiplied 2, because each molecule has 2 nitrogen atoms. B. 16 grams of S8. So 16 by what is S8? Sulfur is 32 into 8. 2. 1 by 16 moles. Now 1 by 16 moles of S8. So number of atoms of sulfur will be equal to 1 by 16 into 8 into Avogadro's number, that will give us 0.5 Na. Right? So this A option is wrong, because already from A, less amount we got already for the B option. Let's see for the C option. C option, number of moles equals to 10 gram divided by molar mass of C6H12O6 is 180 gram. You do your own, first calculate the molar mass. So we'll get 1 by 18 moles. Right? Number of atoms, that will be equal to C6, means 6 A 12A 6Ca. So 24. So 24 by 18 into Na, which is equal to 9, 12, 4, 3. So 4 by 3 Na, which is greater than 1 Na. So our correct answer is option B. Option B has the least number of atoms present, which is 0.5 multiply with the Avogadro's number. Okay. Is it clear? So this is one way of solving the question, where the questions are based on this grams are given, you are finding out the number of entities. It can be other way around also, where you are given with the number of entities and you have to find out the weight of it. For example, question. Find out the mass of SO2 if mass of 12.044 into 10 raised to power 20 molecules of SO2. Fine. Now we have used the formula in this direction, right? This is the time we are going to use in this direction. So what we can do is we can first find out the number of moles. So number of moles is equal to 12.044 into 10 raised to power 20 molecules given divided by 6.022 into 10 raised to power 23 molecules. So this is 2 by 1000 moles, right? Now we got the number of moles. Can we calculate the number of, gram of it? So number of moles is equal to gram given divided by gram molecular mass, which is equal to 2 by 1000. What is gram given? Let it be X, and it is SO2. SO2 is 32 plus 32, 64. So X comes 2 into 64 by 1000, which is equal to, it's equal to 128 by 1000, which is equal to 0.128 grams. Means if there are 0.128 grams of SO2 molecules, then the number of molecules of SO2 present in it will be 12.044 into 10 raised to 20 molecules. Okay, so this is the other way of solving the similar type of question. Is it clear? Let's do one more question which has all the subparts that are possible for this given formula. Okay. Find out the number of, 49 gram of H2SO4 is given. Find out moles of H2SO4, molecules of H2SO4, number of atoms of hydrogen, number of atoms of sulfur, number of atoms of oxygen, gram atom of oxygen, and number of weight or mass of hydrogen molecule, mass of sulfur atom. Okay, so these are the most probable questions that are asked, or like that can be formed from this given statement. Fine. So the very first thing is we are given with the gram, right? The very first thing we are supposed to do is, let me change the color of pen. We are supposed to do is calculate the number of moles of this H2SO4 molecule. So number of moles of H2SO4 molecule will be equal to 49 gram divided by 98 gram per mole, which will give us 0.5 mole. Okay, so the first option, the answer is 0.5 mole. Now, if we know the number of moles, we can find out the number of molecules. What we have to do is number of moles equals to number of molecules divided by Na molecules, right? This is the formula. We have 0.5 mole equals to X upon Na. So X is equal to 0.5 Na molecules of H2SO4. So here it is 3.011 into 10 raised to power 23 molecules. Right? Simple. Next is number of atoms of hydrogen. We know the number of molecules of H2SO4, right? And each molecule contains 2 hydrogen atom. So number of hydrogen atom in H2SO4 molecules will be equal to 2 into 0.5 Na, which is equal to Na number of atoms. So the answer to the third part is 6.022 into 10 raised to the power 23 atoms. Right? Next is number of sulfur atoms. See, in each molecule, the number of sulfur in one molecule of H2SO4 is 1 only. So whatever the moles of H2SO4 will be present, same will be the moles of sulfur, and same with the number of sulfur atoms also. So it will be 3.011 into 10 raised to the power 23 atoms. Okay. Next part is number of atoms of oxygen. Again, one molecule of H2SO4 contains 4 atoms of oxygen, right? So, number of moles of H2SO4 multiply Avogadro's number multiply 4, which is equal to 0.5 into Na into 4, which is 2Na. 2Na means 12.044 into 10 raised to the power 23 atoms. Okay. Next is gram atom of oxygen. This term gram atom means nothing but moles. Okay. This is important. Sometimes in the paper they asked, instead of directly asking for moles, they ask for gram atoms. So gram atom is nothing else but number of moles. So number of moles of oxygen atoms, same. You already know, we need not to multiply it with the Avogadro's number. This is 2 moles. Right? 0.5 into 4, that is 2 moles. Fine. Next is mass of hydrogen molecule. Now, how many hydrogen molecules are present? How many hydrogen molecules are present? We have this much number of hydrogen atoms. If we have to convert it with molecule, we have to divide with 2, right? So 6.022 into 10 raised to the power 23 by 2. These are the hydrogen molecules present. And what is the mass of each molecule? Or instead, if we know the number of moles, that is 0.5 mole, and 1 mole of mass is 1 gram, so 0.5 gram, 0.5 gram. Fine. Mass of sulfur atom. Now, number of moles of sulfur atom is how much? We have this much number of moles of H2SO4 should be equal to number of moles of sulfur atom, right? Which is 0.5. So sulfur atom ke moles. 1 mole ka is 32 gram. So 0.5 into 32, that is 16 gram of sulfur atoms. Clear? Is this clear? This is really, really important and an easy concept to understand. Okay, guys, if you face any doubt, any problem in solving the questions, in understanding the concept, please make sure you are commenting in the comment section. Okay, it will help me to understand which all concepts I should include further in my videos to make it easier for you guys to understand. Okay, clear? Any doubt? Okay, next, see, we have so far discussed that the number of moles can be expressed either as gram given by molar mass or number of entities divided by Avogadro entities, right? But there is another way of defining it. What is it? 1 mole of gas at STP occupies 22.4 liter of volume. What does this mean? First, what is STP? STP stands for standard temperature and pressure conditions, which is equal to temperature is equal to 273 Kelvin and pressure is equal to 1 atmosphere. Means if there is a gas which is kept at 273 Kelvin and 1 atmosphere pressure, the 1 mole of that gas will occupy 22.4 liter of volume. Okay. So can I call it as molar volume is equal to, molar volume means volume occupied by 1 mole of gas at STP is 22.4 liters or 22.4 decimeter cube, right? Or if I change the unit, I can write 22400 ml or 22400 centimeter cube, right? So there's another way of now calculating the number of moles, volume given by molar volume, right? Now there are three components. If I have to write this formula again, let me write down at the center number of moles. One is gram given by molar mass. Okay. The other one is number of entities divided by Avogadro entities. And the third one that we just did is volume given by molar volume. Okay. Now the question can come. So there can be different circles. This is one type of question where you are supposed to find the number of moles if the volume given is given, or you have to find out the volume if the number of moles is given. It can be the other way also. Once again. It can be this also, where you are given with the volume, you had to calculate the mass, or you are given with the mass, you have to find out the volume. And there's a third circle, which is this one, where you are given with the volume, you are supposed to find out the number of entities, or if you are given with number of entities, you are supposed to find out the volume. These are the three set of questions that can be formed with these formulas. Okay. So let's do some questions one by one. Find out the number of moles of CO2 gas that occupies 44.8 liter of volume at STP. Very easy question, very direct question. We have to find the number of moles. So number of moles is volume given by molar volume. So what is the volume given? 44.8 liter. What is the volume of 1 mole? 22.4 liter per mole, which gives us 2. So number of moles is 2 mole. Okay. Fine. Next step of the question. Find out the volume occupied by SO2 gas at volume occupied by 4 moles, let's do 0.25 moles of SO2 gas at STP. Okay, this is the same set of question. It's the other way around. Okay, so what is the answer here? Number of moles equals to volume given divided by molar volume. So now we are given with the number of moles, which is 0.25 multiply 22.4 liter per mole gives to the volume. So the volume comes out to be 5.6 liter. Okay. This is the first set of question where we are dealing with the number of moles and the volume. Okay, let's go with the second type. Find out the number of atoms. But instead of atoms, let's take molecule first. Number of molecule of SO2 gas present in 11.2 liter at STP. Okay. Now what we are given? We are given with the volume. What we have to find out? We have to find out the number of molecules. So the way is, first find out the number of moles. So number of moles is equal to 11.2 liter divided by 22.4 liter per mole, which gives us 0.5 mole. Okay. And number of molecules will be equal to Na molecule equal to number of moles, right? So can I write number of molecules of SO2 equals to 0.5 into Na, which is 3.011 into 10 raised to power 23 molecules. Okay. Same way, in the similar question, if they would have asked for oxygen atoms. So we know one molecule contains two oxygen atoms, and how many molecules we have? This much molecules. So number of oxygen atoms in 3.011 into 10 raised to power 23 molecules of SO2 will be equal to 2 multiply 3.011 into 10 raised to power 23, which gives us 0.22 into 10 raised to power 23 atoms. Okay. Is it clear? Very simple question. Very, very, very simple question. Okay. Let's take the other type, let's the other version of it. Now, in this, we were given with the volume now, and we have to find out the atoms. Here we are given with the atoms and we have to find out the volume. Calculate the volume occupied by CO2 gas at STP if 12.4044 into 10 raised to power 20 atoms of oxygen is present. Now what we are given? We are given with the number of oxygen atoms, right? So number of oxygen atoms, can we first find out the number of molecules that are present? Or first let's find out the number and then we'll find out the number of moles, right? So one molecule may, how many oxygen atoms are there? In CO2, two oxygen atoms, right? So one oxygen atom is present in 0.5 molecule, right? So in this much amount of atoms, what are the number of CO2 molecules? 12.02244 into 10 raised by 20 divided by 2. This gives it 0.022 into 10 raised by 20. 3 molecules of CO2, right? These are the molecules of CO2. Now we got the molecules of CO2. What are we supposed to find out? We have to we are found out number of moles. So number of moles is 6.022 and raised by 20 divided by 6.022 into 10 raised by 23. So we did 10 raised to power minus 3 moles. And then the volume is equal to number of moles multiplied by molar volume, which will be equal to 10 raised to power minus 3 moles multiplied by 22.4 liter. This gives us 0.0224 liter. This is the volume of CO2 gas that it occupies at STP if this is the given number of atoms of oxygen present in it. Okay, is it clear? Next, the third type is for the grams. Weight. Okay. Find out the mass of CO2 gas if it occupies 12 liter. No. Let's take a multiple of 22.4 only. 44.8 liter at ST. Okay. Simple. What are we given with? Volume. So number of moles will be equal to 44.8 liter by 22.4 liter by mole. 2 moles. Then mass means gram given by molar mass equals to 2. So gram will be equal to 2 into 44. That is 88 grams. Okay. The other way is find out the volume occupied by 64 gram of oxygen molecules. Okay. Very, very, very simple question. Now you guys should be able to do it your own, but let me solve it for you. So number of moles equals to 64 gram, 32 gram per mole. Gives us 2 moles, right? Now volume will be equal to 2 multiply 22.4 liter, which is 44.8 liter. Is it clear, guys? So these are certain type of questions that we deal with mole concept. There is another one set where we are going to deal with the stoichiometry of the reactions, but I hope we'll be doing that in the next video. I hope this video is clear. It covers most type of the question that comes in introductory part of stoichiometry. In case you like the video, please, please, please share the video, subscribe the channel, and please make sure that your friends and your known also get the video to see. Fine. Parallelly, please practice the questions that are related to the topic that we have discussed in the video. Try doing as much questions as possible. And if in case you have any doubt, please put it in the comment section. Okay. Thank you so much.